Here's the answer to day 3, problem 1. Use synthetic division to divide this polynomial by x minus 1. For synthetic division, we write the coefficients of all the terms of the polynomial, starting with the highest degree term first. This is 1x cubed, so the leading coefficient is 1. Then we have negative 2x squared, so the next coefficient is negative 2. Then plus 1x, so a 1, and then minus 1. So a negative 1. Here are the 4 coefficients from all of those terms. Synthetic division bracket looks like this. And we're going to divide by a number out front. What we're dividing by is the polynomial x minus 1. If we think of x minus 1 being equal to 0, the value of x that would make it equal to 0 is 1. And that's the number that gets written out front. Bring down the first number, and then multiply these together. 1 times 1 is 1. Add these together, that's negative 1. Multiply these, which is negative 1, and then add 0. Multiply these together, 0, and then add these, negative 1. This last number here is the remainder of our expression. If it had turned out to be 0, then this polynomial would have divided evenly into the original polynomial. But that's not the case. There is a remainder. Separate the remainder away from the other coefficients. And then begin here. This is the constant term. This goes with the x term, and this goes with the x squared term. So our answer is 1x squared. I'm not actually going to write a 1 in front of it. And then minus 1x. I'm just going to write minus x, not actually put a 1 in front of it. And then the constant is plus 0. I'm not going to actually even write plus 0. Then the remainder is plus negative 1 over the divisor. And our divisor was x minus 1. So this polynomial is what we get when we divide x minus 1 into that polynomial. Day 3, problem 2. Evaluate these expressions. The log base 2 of 32. To figure out a log, you start with the base, and you figure out what exponent is needed to create the argument of the log, which is 32. 2 to what power is 32? 2 to the 5th power is 32. And so that answer is 5. Question B, the natural log of e to the x minus 1. The base of a natural log expression is e, and we want to find out what power is needed to equal e to the x minus 1. And that answer is x minus 1. Question C, log base 10 of 1. The base is 10. What power do you raise 10 to equal 1? 10 to the 0 power is equal to 1, so that log is equal to 0.